Okay, so this video is about creating an equation for a quadratic function. Okay, so and we are going to look at the difference in a linear function and a quadratic function. Okay, so we're going to put our tables in there and then we're going to see if it's quadratic. Okay, so let's look at the scenario. It's a football is kicked into the air with an initial upward velocity of 82 feet per second. Its height in feet is recorded at various speeds or seconds. So our t, our time, is going to be our x, and our h is going to be our height. Okay, so I'm just going to put the values of these this table into Desmos. Now we did this with linear functions. Do you remember that? Okay, we put in a table and then we came up with an equation. So let's do that. In Desmos, we're going to go over here. I'm going to see if I can move this so you can see it. We're going to add a table. Okay, and we have 0 through 4. Alright, and then our y values were 0, 66, 100, 102, and 72. Okay, so what I want you to see are where your dots are. Okay, so let's look at our dots. We'll pull this down so you can see it. Alright, they're kind of weird looking, so make sure I wrote everything correctly. Okay, and we want to see if we can get right here it says, is this linear or quadratic? And then they want to know how high the ball went after 5 seconds. Okay, now this is going to be quadratic because you know how it is when the ball is kicked. It goes up in the air, arches, and comes back down. So we're going to put our table in using the standard form of the quadratic equation, or quadratic equation. And that is this right here. Notice what I did with my y's and my x's. I put a 1 in them. Remember, we did this with linear, but this is a quadratic function, so we have to use that format. So y1, and then we get the little mark beside the 1, and we go ax1 raised to the square. So notice what that does. It put the base 1, but it also raised the ax to the square. Then we're going to put plus bx and then plus c. And those are our functions or our values, but you must put a 1 with all the x's and the y's. Okay? Alright. So it gives us our values. Look down here and you see them. Okay? A is negative 16 and B is 82. Alright? And C, you notice it has an exponent of negative 15 on the 10. That's basically 0. So negative 16 and 82. So y equals negative 16x squared plus 82x. And we had 0 for C, so you didn't need that. Now, they want to know height of the ball after 5 seconds. All right, now remember seconds is your x value. Okay, so notice my x-intercept is at 5.125. Okay, I'm going to go over here and I'm just going to use the equation that I created. Negative 16, and I'm going to put that 5 seconds in for x and square it. And then I'm going to add 82. And again, I'm going to put that 5 in for x. Okay, so once I know what my equation is, I could put any number of seconds here and it will tell me how high the ball is. Notice it did solve it right here. Okay, so your ball is 10 feet in the air. So let's go right back here and it says per second, after 5 seconds, we were at 10 feet. Okay, All right, let's look at this one. A frog is jumping into a lily pad. So a frog's jump is a parabola as well, right? Okay, so we're going to put this table into our graph or into our table. And remember what I told you when we were doing this for the test. We don't get rid of the table, we just change the numbers in the table, right? So we're going to change these. All right. Okay, so there's our graph. And notice it did change our equation, right? Changed our equation. Now A is negative 1/2, B is 3, and C is 2. Okay? So we have y equals negative 1/2 x squared. Our B was 3 and C is 2. Plus 3x plus 2. So that's our equation. And then it says its height is recorded in the table. So how high was the frog, or how long did it take the frog to get back to the ground? Let's answer that question. How long did, oh, there's our question. The height of the frog after 6 seconds, okay? So remember I told you we could take the equation we created, negative 0.5. Instead of x, we're going to put, what did we say, 6 seconds? And we're going to square it. And then we're going to add 3 times that 6 seconds again. And then we're going to add our c, which is a 2. So 2 feet is where he would be after 6 seconds. Okay? Now I got one more example to show you. And this says the tables below shows the number of students enrolled in this high school. Now I want you to notice something about the numbers. See how the numbers continue to go up. This is a linear equation. So if we were going to put this table in, we would have to use a linear function. Okay? So our equations for this unit are quadratic. And when you put them in Desmos as a table, remember this is the form of your equation that you have to use. Okay?